And when it arrived, we connected it to that machine over there, which is our time-shared computer for the computer science department. And we sent bits back and forth. But that was not yet a network. It was one node. So if you turn around over here, you'll see the architecture. I just described this machine behind me, Sigma 7, and SDS Sigma 7. That's the imp over there. And we can move bits back and forth. That was September 1969. In October 69, a second switch was delivered 400 miles to the north at Stanford Research Institute. They already were running their time-shared computer. They connected it, and BB then leased a high-speed link between the two. This is the first piece of the internet backbone ever, running at the blazing speed of 50,000 bits per second.
Huge.
Huge. It was huge that time. Today, it's not worth paying for. And so now we had a two-node network, and we said, let's connect them. Now, the way this network was designed to be used was that here we are, say, at UCLA, and there are resources out there in the network that are very specialized, like Utah happened to have excellent graphics processor, and SRI has a good database. And as the network expanded, we got more and more capability. So the idea was, if I wanted to do some graphics, one choice was to take all that capability and replicate it here. And all the other things replicate everywhere, because that's not economically feasible. That's the reason the agency that was funding all of this, the Advanced Research Projects Agency, part of the Department of Defense, decided connect these things to the network so you can share resources. So in order to share resources, if I'm sitting here and I want to use this machine, I have to log on to that machine and start running my programs there. And as far as this machine is concerned, it doesn't know if I'm coming in locally, like a regular user, or coming through this port, which happens to be connected to the network. So our only job is, in the first attempt to use this thing, is to log in from here to there. Okay? So we had my programmer down here, Charlie Klein, sitting at that teletype machine there, and Bill Duval up north. And in order to log in, you have to type L-O-G. And the machine up there is really smart. It knows when you're doing it, it'll type the IN for you. So here we go. Let's get ready. But you know, this is the first time we're going to send data through this complicated network here, these new switches. So we had a telephone connection connecting us to them. Now look at the irony of this thing. We're using the telephone network to prove out a new technology which is going to destroy the telephone system. They didn't know. So we got on the phone and Charlie typed the L and said, "You get the L?" And Bill said, "Yep, got the L." Got the O, you get the O? Yep, got the O. Type the G, you get the G? Crash. So the first message ever on the network was low. As in, lo and behold. I spent an hour or so watching the site. Now, you understand, we didn't plan that. We didn't expect this would be important. You know, Neil Armstrong, Giant Leap for Mankind, cameras, telephone, television, all the rest. We didn't understand it. We had no sense of public relations or media. We just wanted to run an experiment. Or Alexander Graham Bell or Samuel Morse, they had great messages. But it turns out that our message is the most succinct, most prophetic, most profound message we could have cooked up. So by accident, it turns out to be a good message. Now,
there was a previous question about the future governance of the internet. Can you say something about the present governance? If new technology develops, who controls it? Who sees that it's implemented? And so on?
well, you know, there was a time when the Department of Defense ran things through this funding, and then it launched out and industry began to take over. It's in private hands right now. There is this overall governing body called ICANN, which you've heard about. There's offices here in California, in fact. And they control things like the numbering system and the allocation of those resources. But the
world is complaining that it's too heavily controlled by the United States. You heard that ITU, which used to be called the CCITT, the International Traffic Union, is taking over some functionality as well. It's an international body. And so the control is being spread out across the world, which is a good thing. How far it can go is not clear. I mean, if it's totally spread out, there may be no progress. And when conflicts come up, what do you do about it? So it's again a political football. It's not totally clear what's happening, but having the United States continue to control is not sustainable. And that has been the case for a long time.